Hi guys, I'm going to do a quick video on finding real limits and filling out a grouped frequency distribution table. So there's going to be some follow-up questions to this question as well, but I think I might cover those in a separate video. But right now I just really want to hit this hard because, once you do several practice problems, you get the hang of it, but for some people these can be a little challenging at first. So the first thing that we're going to discuss with this is the idea of real limits. So, by the way, this is from the homework packet worksheet for chapters 1 through 3, and it's question 9. So, this is based on a question. OU students were asked, how many phone calls did you receive last night? And then here we just have their responses. It was 20 people, so each one of their responses are listed here. So this here is called the apparent limits, because our goal here is to place these numbers here into groups based on the intervals. So instead of having a table where it's like 1, 2, 3, 4, 5, 6, 7, and going clear through and having 11 different intervals, we're going to put them into groups so that it's a little bit more condensed. So the only issue with that is that these apparent limits here, they don't cover all of the possibilities for a continuous distribution. So we have to account for that with real limits. These are our apparent limits. We got to account. These are our apparent limits. We've got to account for that with our real limits. So the way I'm going to do that is I'm going to say that the real limits of this first interval here are negative 0.5 to positive 1.5. And then for this 2 to 3 group, it's going to be 1.5 to 3.5. Notice that these two numbers are the same. This is our upper real limit. For this group, this 1.5 is called the upper real limit. For this group, this is our lower real limit. The upper real limit for one interval is going to be the same value as the lower real limit for the following interval. Because like I said, we want to cover each one of the possible values. So you might think that you could have 1.5 here and then 1.6 here, so that it wouldn't be the same value. But that just wouldn't be correct, because that doesn't account for numbers like 1.57, right? So that's why our upper real limit for one is the same as the lower real limit for the next one. So our apparent limits for the interval 2 to 3 is actually 1.5 to 3.5. So like I said, the upper real limit for the last one is going to be our lower real limit for this one. So we're going to do 3.5 to 5.5, 5.5 to 7.5, 7.5 to 9.5, and then 9.5 to 11.5. So notice also that the upper real limit, oops, I didn't mean to use that one. The upper real limit and the lower real limit represent the halfway point between the upper apparent limit and the lower apparent limit. So hopefully you can kind of see that pattern there and understand where that came from. So the next thing that we're going to find is the midpoint. The way that we're going to find the midpoint is to add the upper and the lower real limit and divide by 2. So like find the average kind of. So the same way that you would find an average between a group of numbers is the same way we're going to do this. So I am going to do negative 0.5 plus 1.5, and just so you realize, like, this isn't a negative sign, that's just showing the range. So anyway, negative 1.5 plus 1.5 equals 1, and then since there's 2 numbers here, we're just going to divide that by 2, and that gives us 1/2 or 0.5. So that's our midpoint for this number. I'm sorry, for that interval. Same thing for the next one. We're going to do 1.5 plus 3.5. And that is going to give us 5. We're going to divide that by 2. And that's 2.5. So like I said, we're just finding like the average between these 2 numbers. Um, 3.5 plus 5.5 is going to be 9. So that one's going to be 4.5. 9 divided by 2 is 4.5. 7.5 plus 5.5, that's going to be 13. Divided by 2 is 6.5. 7.5 plus 9.5, that is going to be 17. Divided by 2 is 8.5. And 9.5 plus 11.5 is going to be, 21.5. Divided by 2 is going to be 10.5. Now we have to find the frequency for each interval. So we have our our responses here. So I'm just going to go through and count how many of these responses fall between negative 0.5 and 1.5. So we've got 1, 2, 3. So I'm seeing 3 responses for that one. So I'm going to write 3 here. We're going to find how many fall between 1.5 and 3.5. So we've got 1, 2, 3, 4, 5, 6. Next, between 3.5 and 5.5, 1, 2, 3, 4, 5. I'm seeing 5. Yeah, it's like 4 in the morning, so hopefully I'm counting these correctly. We'll notice at the end though if we did something wrong. So 5.5 and 7.5, we've got 1, 2, 3, 3. 7.5 and 9.5. So we've got, do we have any on that one? I'm not seeing any for that one. And then 9.5 to 11.5. So 1, 2, looks like 2. Alrighty, so how I'm going to check this is that this should add up to 20. This should add up to 20 since we had 20 here. So 3 plus 6 is 9, plus 5 is 14, plus 3 is 17, plus 2 is 19. So I must have missed one here. I figured, like I said, I'm pretty tired. So let me just do this real quickly again to see what I missed. So between -5 and 1.5, we've got 1, 2, 3. Between 1.5 and 3.5, we've got 1, 2, 3, 4, 5. How did I get 6 for that? Sorry, one more time. 1, 2, 3, 4, 5, 6. Okay, that's right. Between 3.5 and 5.5, let's see here. So 1, 2, 3, 4, 5. Okay. Between 5.5 and 7.5, 1, 2, 3, 4. Okay, that's what I did. I think I overlooked that little 7 there the first time, maybe. So this one is actually 4. Alrighty. So, the next thing we have to do is cumulative frequency. So the way we find cumulative frequency is we add, so basically we see how many frequencies there are so far, how many occurrences there are so far. Again, I'm not always the best with language or words, but I think once you see the example, it'll make sense. So this here is our very first interval. So there were no occurrences before this interval, so it's just going to be this. The first cumulative frequency always equals the first general frequency. For this one, however, I'm going to add this frequency with this frequency. Okay? So that is going to be 9. Now, another way to say that, and probably a better way, is that I added this frequency with this frequency. Because it's the same number, obviously it doesn't matter for the first one. But for this frequency here, I am going to add this with this. So let's do this. So that's 14. So I'm going to add 14 and 4 to get 18. 18 and 0 is 18. 18 and 2 plus 20. So you see what I did there? The first, because, the first one, like we said, there's no occurrences before it. So 3, the cumulative frequency would be 3. Find the next one, we added this to this and got this, and hopefully that makes sense. You just, add them on, and at the end, it should always equal however many people were in your sample. So, because, there's going to be 20 occurrences overall, so your last cumulative frequency point should be whatever the number in the sample was. So, the next thing we're going to find is the relative percentage. We're going to find this by dividing this frequency by the total number in our sample, which is 20. So I'm going to just draw an arrow from the relative percentage to the frequency so that we don't mess up and look at these numbers instead of these numbers. So the first thing I'm going to do is 3 divided by 20, which is 15%, because it would be 0.15. We just moved that decimal place over 2, and it's 15%. I'm going to do 6 divided by 20, which is 30%. 5 divided by 20 is 25%. 4 divided by 20 is 20%. 0 divided by 20 is 0%. And then 2 divided by 20 is 10%. So hopefully that makes sense for that one. And then for the cumulative percentage, we're going to do the same thing, except with this column of numbers. So this is getting a little bit messy here, but hopefully you're able to see what's going on. I'm actually going to use a different color, I think, just to make things a little bit clearer. So this first one here is going to be the same. 3 divided by 20 is 15%. But for this next one, we're going to do 9 divided by 20, which is 45%. 14 divided by 20 is 70%. 18 divided by 20 is 90%. This is going to be 18 divided by 20 again. 90%. And then 20 divided by 20 is 100%. This one here should always, always, always be 100%. And another thing that you'll notice is that this number plus this number equals this number. So that's a way to either double check yourself or do it quickly, is just by adding those up. 45 plus 25 equals 70. 70 plus 20 equals 90. 90 plus 90 plus 0 equals 90. And then 90 plus 10 equals 100. So these tables are actually, kind of satisfying. when it comes down to it, because there's a bunch of different ways to check yourself, and you just notice that things add up pretty nicely. So I am going to erase what we have so far and just rewrite the actual values without all these funky arrows and all of that. So we can do the following problems that relate to it without having to look through all those arrows and stuff like that. So 4, 0, 2, 3, 9, 14, 18, 18, 20. I have these written on a paper over here next to me, which is how I didn't just memorize these off the top of my head. I could do it again if I needed to, but we don't need to use all that brain power at 4 in the morning, right? 15%, 45%, 70%, 90%, 90%, and then 100%. Okay, so if you want to see me answer questions 10 through 13, go ahead and watch my next video.